Hello, and welcome to the Pre-Calculus Podcast. I am your host. Today we're looking at uh, circles and ellipses. Okay, circles and ellipses as we continue on to this whole section on conic sections. And last time we talked about parabolas. Now we're going to be looking at circles and ellipses before I move on to um, the next topic. So first thing is a circle. So what a circle is a set of points on a plane that are equidistant from a fixed point. And that's what a circle is. It's a locus of points or a set of points from a single point. So if I'm looking for all points that are 1 inch away from this point right here, so I'm looking for all points 1 inch away from there, what ends up happening is we end up getting a circle. Now the equation for a circle is x minus h squared plus y minus k squared equals to r squared, where the center of the circle is located at hk. This is again putting it on some sort of Cartesian plane or a coordinate plane, and r is equal to the radius. Okay, so if you notice in this equation, the r is squared. You have to take that square root of what it's equal to get your radius. Okay. All right. So a lot of this shouldn't be anything super new, but it is something that we have. So let's say we have this equation and we want to find our radius and our center. So as you see, we have the x squared plus y squared minus 14x plus 14 or 4y is equal to 11. And what we want to do is we want to get it set up into the equation of x minus h squared plus y minus k squared equals r squared. Okay, so we want to get those parentheses squared. Now the way to do that is by using our completion of the square. So what I've done here is I've moved the x's and the y's together. Okay, so we've got our x squared minus 14x, y squared plus 4y, and then the 11. Now what I've added here is I've added the 49 and the 4. Now I got those numbers by using completion of the square, because what I want to do is I want to turn this into a square and this into the square. So I'm going to do 2 completion of the square, which would end up being b over 2a squared. So I took 14, half of 14 is 7, 7 squared is 49, so that's why I added 49 to both sides. 4, half of 4 is 2, squared is 4, so that's why I added it to both sides. So I've done a completion of the square twice on this to get it. Now this first part ends up being x minus 7 squared. The second parenthesis becomes x plus 2 squared. And then I added all of these together to get 64. Okay, so when you're given just an equation, what you want to do is you want to use completion of the square to get it all the way through. Now if you have a value in front of the x squared or the y squared, either A, see if you can reduce it out, or B, just divide it all the way through so you get a nice whole number. That's kind of the goal. So there is our equation. So now what is the center of this circle? That's right, the center of the circle would be 7 comma negative 2. And what's the radius of this circle? That would be the square root of 8, or square root of 64, which is 8. So 8 units with a radius of 8 and a center of 7, 2. Okay, and that's circles. Most of this stuff shouldn't be brand new. It's stuff that we have gone over in previous classes. Okay. All right, so now is time for a ad, I guess. And so today's ad is about here. It is about Soylent Green. Wait a second. Isn't that made of people? Today's episode is brought to you by Soylent Green. Soylent Green, the food made for people, by people, and of people. Find it at your local store. All right, back to our normal program. We've got an ellipse next. So an ellipse is a set of points on a plane that's whose sum is the distance from two fixed points, and those two fixed points are your foci. Okay, so if you remember foci from parabolas, their two fixed points are your foci of the ellipse, and if they're constant, then it wants to know what the sum of the differences is. So if I take 2 points here and here, okay, and if I find a point that's fixed, so let's say here, say I draw an ellipse around this, okay. If this was a perfect ellipse, the distance from, let's do it in a different color, the distance from this to that point and there, that distance is going to be the same as if I went from here to here, okay, and that distance is going to be the same if I went from here to there, if I went the entire distance to that point from those. So if you take each of these segments and add them up to each point, they should all be the same, and that's how we make an ellipse. Okay, you can do this if you think about it, if you pin down like a piece of string at 2 points that is a little loose in between, and then if you extend it as tight as possible, you end up making an ellipse. Okay, the center is the midpoint of the two foci. So when we're talking about the center, we're talking about the point that's right in the middle of it. So with an ellipse, we have our major and minor axes. So our major axis is the large arc. Okay, so it's the bigger one. So this one right here is your major axis, and then your minor axis is the smaller one. Okay, and usually when we're talking about our axes, we're talking about the line in it. So in this case, the y-axis would be your minor, and your x-axis would be your major, because the x-axis is wider. It's a longer distance. The longer the distance, it's a major axis. Okay, one's going to be longer than the other NE ellipse. Alright, so now looking at an equation with an ellipse, there's two different types of ellipse we can have. We can have a horizontal or a vertical ellipse. Now this is a horizontal ellipse because the horizontal axis is your major axis. So going left to right is bigger. So the equation would be x squared over a squared plus y squared over b squared is equal to 1. Okay, and it's horizontal if the a is larger than the b. Okay, so if a is bigger than b, then it's horizontal. And again, you're taking the square root of it. The vertices, which are always on the major axes, is going to be negative a0 and a0 because this is located at the center. It's not being moved anywhere. And then the y-intercepts would be 0 comma negative b and 0b. Okay. All right. So again, the vertices are always going to be located at a major axis. Okay. So those could be up at b and d if it was the other way, which we're going to look. Your foci is found by taking negative c0 and c0. Okay, where c is equal to, or c squared is equal to a squared minus b squared. So you take the difference of the bigger minus the smaller of the squareds, and then you square root it, and that's how you get your c. Okay, and your foci is going to be located always somewhere closer to the major axis, or to the vertices, than on the major axis, not on the minor axis. Okay, so that's if it's horizontal. Now, if it's vertical, everything's just switched. So the it's x squared over b squared plus y squared over a squared equals 1, in which the a is again larger than the b. So the bigger number. So if the bigger number is underneath the y, that means it's going to be vertical. If the bigger number is underneath the x, it's going to be horizontal. And now all your points basically have just switched. So your vertices are now at 0, negative a, and 0a, and then you're finding your x-intercept, which is at negative b0 and b0. Foci is the same formula to find the c, but now it's the y value that's changing, not the x. So if it's a vertical ellipse, the y value is going to be changing. Okay, so let's say we have an ellipse and we want to write it in standard form. So if we want to write it in standard form, what we're going to have to do is we have to get it into the formula that we had before, where it's x squared all by itself and y squared all by itself. So we have to divide everything through. So if we want to divide it so that everything gets rid of it, so that we have no coefficient in front of the x and y, we have to find out what that number would be. So in this case, the easiest way of doing it is if we look at what it's equal to. So what it's equal to is 144. Well, if you look at all the previous equations, what we wanted it equal to was equal to 1. So what do we have to do to 144 to equal 1? We have to divide it by 144. Now when we divide each of the other numbers by 144, we end up getting it reducing nicely. Sometimes it won't reduce as nicely, which in that case you can use decimals for it or anything like that. But this one works out pretty nice. So we have x squared over 9 plus y squared over 16 is equal to 1, which then changed if you change it to the squares of those. So my first question is it a vertical ellipse or is it a horizontal ellipse? And since the number underneath the y is larger, we would say it's a vertical ellipse. Okay, so it's a vertical ellipse. So now, here's all our numbers for our vertices. Since it's a vertical ellipse, that means the y is changing. Okay. Oh, it should be 4. 2, actually. 2. And this should be, oh no, this should be 4 and 4. And this should be 3 and 3. Okay. So this should be reversed because it's a vertical, which means then it should be the y is changing. So whoever edited this did a terrible job. I don't care. You gotta be kidding me. Didn't proofread this? Terrible. Terrible. I don't even know what to say anymore. Alright. Horizontal if it's not located at the center. So if it's not located at the center, you're going to have h minus, or x minus h squared and y minus k squared. And then in this case, what you're going to do to find the vertices is that you find your center, hk, and everything's now just kind of shifted by hk. Okay, the length of the minor axis is 2b. The foci is based off the center, and you plus or minus the c. So the only difference here is that you're not located at the center anymore. You're located at a point hk, which then fluctuates and moves everything, a for the vertices and c for the foci. Okay, and if it's horizontal, you're adjusting the x values, not the y values. Okay, vertical is just the opposite. Okay, so the hk again, but now you're adjusting the k values, not the h values. Okay, and so if the bigger number's underneath the y, that means that the k values are changing, not the h values. Okay, so the h values stay as is. Alright, so take a second here, find what the center is. Okay, so the center of this is at 1, 2. 1, 2 is your center. Okay. And then what we want to do is we want to graph it. So now what we have to do is we have to find, okay, how far on each. Now the distance for each one is basically just taking the square root of the bottom. So once you have that center, square root of 9 is 3, so we move over 3, 1, 2, 3. And we go over 3, 1, 2, 3. And then square root of 4 is 2, 1, 2, 1, 2. And so there would be our ellipse. Okay. So there would be our ellipse. So we graph it. It's horizontal because the 9's bigger. So that means our vertices are at negative 2, 2, and 4, 2. Oh, yeah. And 4, 2. And then our minor axis is a distance of 4. Our foci are going to be located there because what we would do is we'd go 9 minus 4 gets us 5, and we take the square root of 5. Okay, which is why you go 1 minus 5 and 1 plus 5, because that's where the foci are. So the foci are going to be located somewhere, in here-ish. Okay. All right, so that's the end of this section. Here's your homework, and I hope everything's okay.